Okay, so here's an example of a parallel line proof. Okay, so let's look at what we got. Let me write in the given, and then let's look at that. So if this is what we have, say, okay, 2 and 3 are add up to 180. So the first thing I think about, I want to prove L and M. So now I know, hey, this line N, just there to mess with us. So in my head, and I'll do it here, I just get rid of all of this, right? I don't need this. It doesn't help me in any way because I just need L and M. Let's get rid of the extra information. And then I look, I say, okay, for L and M to be parallel, what information do we need? Whoa, wouldn't it be nice if 2 and 6 were supplementary? And my brain goes right to supplementary because, hey, we got supplementary here. So how could I do this? Well, here's something I know. I know that 3 is equal to 6, right? Because vertical angles are congruent. We know that. We can prove that. Okay, so now I'm going to do some substitution to say, hey, 2 plus 6 is equal to 180 degrees. That's substitution. So that means L and M are parallel because if same side interior angles are supplementary, then lines are parallel. Cool? Okay, so here's a proof to try on your own. So take a minute, draw this out, get going, pause the video, and try to do the proof on your own, and then come back and check it with me. Okay, so hopefully you've done this on your own, and you could do it, but I will go through it for you. So as we look at this, I'm going to go through and mark what we know. Okay, so this is what we know. Okay. So when I look at this, in order to prove, I'll do a little thinking. I want these to be parallel. So when I look at the angles that are affected by these, right, it's 2 and 4. Somehow I got to get 2 and 4 congruent. Okay, so what I'm going to say when I do this and I think through this is I'm going to say 1 is equal to 3. Because if lines are parallel, corresponding angles are equal, and those are corresponding angles. And the lines are parallel, right? I'm going to highlight this for you. This line and this line are parallel. So these are the corresponding angles. Okay, so now I'm going to do some substitution. Oh, this is a typo. Sorry, this should be a 4. Apologize. Okay, so in for 3, I'm going to put a 4. And in for 2, I'm going to put, or in for 1, I'm going to put a 2. And this is substitution. It's really 2 substitutions, okay, which is a fine thing to use. And now I'm going to say, oh, now I know BC is parallel to DE because if corresponding angles are congruent, then lines are parallel. I love this proof as practice because you use these 2 theorems that are converses of each other, and it's really important that you note which one you're using, right? Is the hypothesis that the lines are parallel, we have our parallel lines, or is the hypothesis that the corresponding angles are congruent? So make sure this makes sense to you, and if your proof was not like this, go ahead and fix it.